we're almost done reviewing those facilities. You might say, why bother with, it seems like this is a much better alternative because it's more flexible. It allows us, regardless of the fact that, we have to remember maybe to free up memory, then, and use this curious empty square bracket syntax. Maybe this is better than this regular primitive array. Okay. The answer is that both must exist because, allocating our arrays on the stack, which is essentially a local, similar to a local allocation of primitive variables, all of them, is very fast. Whereas this is slow. Because remember, there's for instance, I may be allocating many different things on the free store, right? I could be saying, give me this memory and give me something else and give me something else. And then eventually, there's lots of things going on. And the free store manager really is tricky. It needs to basically build some sort of a tree, which provides access, which internally somehow describes all these locations that were dynamically allocated. So it becomes an overhead at runtime. So, using this free store, and this is pretty much all that, your Java program does, is much slower than using primitive arrays. So anytime you can do this, you should be using a primitive array. This is, a resort for the case where you really don't know what is the array size, and hopefully, you're doing it in a well-mannered way so that you're aware of the fact that, this is a critical matter, that you now should be aware of the fact that you're dealing with memory dynamically. And in many cases, if you're writing software for the server environment and you're expecting your web server to stay up and healthy for months to come in memory without any downtime, you definitely should be saying new and delete in a very balanced way so that you don't create memory leaks, but you also don't do something like this by mistake, so that this will actually corrupt the structure maintained by the free store manager right here. So it will get corrupted. There are many ways to do this and to deal with this, but one of the ways to deal with this, so say there's a there is a lot of code in this particular section of our program. But later on, we want to free up memory. As we say, okay, we're done with this. We want to free up memory. So typically, what is done, and the way potentially this could be done, is that we can say if CHR is not null, maybe something like that, then delete CHRR and also set CHRR equals null. This way, there is a macro simply defined as 0. And C++ standard says that any address which is 0 is an illegal address, and defensively maybe after deletion assign your pointer a null value. To next time, if you run into this code, do not attempt to delete it, because perhaps there is no reason to delete it. Okay, so let's